Hello everybody. The topic of this section is the frequency of compounding. If compounding is done only once per year, the future value FV is equal to the present value PV multiply 1 plus interest rate I to the nth, where n stands for the number of years. But if the compounding frequency is twice or more times per year, how to calculate the FV? In this section, we will discuss this question mainly. Let's get to know two types of rates firstly. The first one is annual percentage rate, or in short, APR. APR refers to the one-year interest rate without considering the compound interest within the year, which generally refers to the interest rate on loan and saving accounts in bank or interest rate indicated on the bonds. Another rate is effective annual rate, EFF, or EAR in short. Here we use EFF. EFF is defined as the equivalent interest rate if compounding were only once per year. EFF is referred to make the interest rate comparable for different frequencies of compounding. What's the relationship between the APR and the EFF? Let's see an example. Suppose your money earns interest at a stated annual percentage rate APR of 6% per year, compounded monthly. This means the interest rate is credited to your account every month at 1/12 of the stated APR. That is, the true interest rate is 6% divided by 12, and the frequency of compounding is 12 times per year. For each dollar we invested at the beginning of the year, we can calculate its future value FV at the end of the year. FV is equal to 1 plus 6% over 12, altogether to the 12th. And then the EFF is equal to this FV minus 1. In general, the formula for the EFF at the APR and the compounding frequency M is equal to 1 plus APR over M altogether to the mth minus the 1, where M is the number of compounding periods per year. Let's do a quiz. Suppose that you take out a loan at an APR of 10% with quarterly compounding. What is the effective annual rate on your loan? In this question, APR is 10% and the compounding frequency M is 4. By the formula of the EFF is equal to 1 plus 10% over 4 altogether to the 4th, and then minus 1. Finally, the EFF is obtained as 10.3813%. This table presents the effective annual rates EFFs corresponding to an annual percentage rate APR of 6% per year for different compounding frequencies. If compounding is done once per year, the EFF is the same as the APR. Well, as the compounding frequency increases, the EFF gets larger and larger but approaches a limit. Let's discuss how to calculate this limit. Consider the condition with continuous compounding. As M increases to infinity by the algebra theory of the limitation, 1 plus APR over M altogether to the mth approaches to the exponential APR. Therefore, the EFF is equal to exponential APR minus 1. So, if the interest is continuously compounded at 6%, the EFF is equal to exponential 6% minus 1, which is almost 6.18365%. If the compounding period is more than 1 year, in generally over n years, the total number of compounding periods is m multiplied n, and the compounding FV is PV multiply 1 plus APR over m altogether to the mnth. With continuous compounding, the FV is calculated as PV multiply exponential APR multiply n. Finally, let's do another quiz. If you invest $1,000 today at an annual percentage rate of 2% per year, how much will you have 3 years from now? Assuming no withdrawals in the interim and the interest is continuously compounded. So PV is $1,000. The APR is 2%. The number of years n is 3 with continuous compounding. By the formula of FV for continuous compounding, FV is equal to PV 1000 multiply exponential APR 2% multiply 3. Therefore, the amount you will have 3 years from now is 1000 exponential 0.06. In summary, we have studied 2 types of REITs: annual percentage rate APR and effective annual rate EFF, and the relationship between these 2 REITs. We also discussed the calculation of FV under the conditions where the frequency of compounding is greater than once per year. That's all about this section. Bye.